Matcom tutorials, an investment in knowledge pays the best interest.
This is the next question. A student investigates the magnification of the image produced by a lens. Figure 3.1 shows the apparatus used. Illuminated object here. The distance between this place and this place is termed u. That is the object distance. The distance between the lens and the screen is v. That is the image distance. There is a bench here. So let's look at it. Figure 3.2 shows a triangular hole in a card that forms the illuminated object. Figure 3.2 is drawn actual size. So on figure 3.2, measure and record the length, the height h naught of the object. All you need to do is to just place your ruler here and record the height between this place and this place. And with that, I got 1.5 cm, 1.5 cm, 1.5 cm. Okay, let's look at the next question. 1.5 cm. The student places the lens at distance u equals 20 cm from the illuminated object. He moves the screen slowly until a clearly focused image is formed on the screen. He measures the distance v between the center of the lens and the screen. He repeats the procedure using values of u equal to 25.0 cm, 30.0 cm, 35.0 centimeters, and 40.0 centimeters. The readings are shown in table 3.1. So this is a table here. Calculate and record in table 3.1 the magnification m for each value of u. Use the equation. So what you need to do is v divided by u. So in this case, you have 70.9 divided by 20. Let's quickly do that. 70.9 divided by 20. I've just told you how to do it. So for others, I will just be writing the values there. 70.9 divided by 20. This will give us 3.55. 3.55. The next one is 41.5 divided by 25, and that gave me 1.66. 1.66. The next one is 32.5 divided by 30.0, and that gave me 1.08. 1.08. And the next one, 28.1 divided by 35, and that gave me 0.80. 0.80. And the last one, 25.6 divided by 40, gave me 0.64. 0.64. Okay, that's the table. What's next? Let's check the next question. Okay. Plot a graph of u in cm cube on the y-axis against m on the x-axis. Start the y-axis at u equals 20 cm. Let me make this graph a little bigger for you to be able to appreciate it. Well, I'm going to show you. So I have my u here. This is my u in cm cube. You see, whenever you want to plot a graph, you must show your axis, because showing your axis, this is u in cm cube on the y-axis, and then the second one, m on the x-axis, that gives you 1 mark. So let's look at the labeling. You've been told to start this from 20. But let's look at our table to know how we are going to choose. Now, for you, it starts with 20 and ends with 40. So let's look at how we are going to choose, because your graph must contain a greater part of the sheet. I mean, your scale must contain a greater part of the sheet. So let's look at it. What do we have here? We have one line, two, three, four, five lines. So what I have done is to do the scale in such a way that it will occupy most of the lines. So we start 20 here. This one, 25. That means 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes will give you 5 units. You need to be very careful in choosing your scale, because there are some scales that are called improper scales or abnormal scales. When you choose a scale that is odd, numbers that cannot be divisible. For example, you are using 10 boxes to represent 3 units or so. That may look somehow, so it's not going to be divisible, but for this, it is divisible. So we have 20 here, 25 here, 30 here, plus 5, 35, 40. And you can see it's only one big box that is left. So, I mean 10 small boxes and one big one that is left. So that is a good scale. Let's now look at on the x-axis. The smallest value is 0.64 and the highest value is 3.55. Let's go to our scaling. So with the scaling I used, 10 small boxes is 0.5. This is 1.0, this is 1.5, 2.0, 2.5, and 3.0, 3.5, wow, 4.0. Can you see I've used 4? So going by the principle of your scale, containing most of your graph sheet, I have done that. Now we have our scale, and then let me bring it back to, okay, I actually enlarged it so that you'll be able to see the boxes very well. Okay, now let's see. Plot a graph. We've just chosen the scale, we've not plotted the graph. So let's see how to plot the graph. How do we plot the graph? I'm still going to make it bigger. How do we plot the graph? We are going to use our values to plot the graph. We're going to use our values to plot the graph. So let's go and check our values. What we are going to do is this. We are plotting this against this. So when u is 20, m will be 3.55. Let's check that. When u is 20, m is 3.55. This is u 20. 20, what will be the value of m? At u20, let me make it a little smaller. Okay. At u20, m is 3.55. So let's mark our m. This is 3.5, 3.6, 3.7, 3.8, 3.9. So this is 3.5 and this will be 3.55. 3.55. Let's see. Okay. Now, that is that. When let's see the other one. When m is 1.66, or when u is 25, m is 1.66. Let's look at that. When u is 25, m is 1.66, 1.5, 1.6. So we have 1.65, 1.66 should be around here, 1.66, and so on. With that, you plot the graph. Let's look at how to plot the graph. Okay, I'll make this one a little bit bigger so that you'll be able to see it. Here I have my points already. If you look at the table, when u is 30, m is 1.08. That's what I did here, 1.08. When u is 35 is 0.80. That's what I have here, 0.80. And when u is 40, it is 0.64. That's what I have here. So I have plotted all my points with crosses, not big blobs, not blobs, with crosses. And now if you look at the point, this is not a case where you draw a line of best fit. There is no line of best fit that you can draw here. We're looking at the point. The points themselves they form the curve. So you have to make your graph a curve like this. Well, don't really mind the way I have drawn it, but I believe your own is going to be smoother than this. So you are going to draw a curve like this, and with that, you have plotted the graph. The question is for you to plot a graph of U against M, and the graph has been plotted here. So what is the next question? Use your graph to determine the value of the object distance U1 when the magnification M equals 1. So let's look at when magnification equals 1. When magnification equals 1, let's look at it. Magnification equals 1. What will be the value of this one when magnification equals 1? So we need to trace this like this. Need to trace it. I think this is the point. Okay. We need to trace it. Okay. That's what we're looking for. I make it a little bit bigger. Okay, bigger. Let's see. When this is 1, this one is here. So let's get the value. This is 30, 30.5, 31. Sorry, 30, 30.5, 31. 31.5 is in between 31 and 31.5. So it is 31.25. 31.25. I believe you understand what I've just done. What I just did, the question was for us to use the graph to determine the value of object distance U1 when the magnification is 1. Now this is the magnification here, 1. You trace it up. When it hits the graph, you now trace it to the U axis and get the value. This is 30, 30.5, 31. This is meant to be 31.5. So in between, you just have 0.25 in between 0.5. So that's how we got that answer. Okay, make it go back to its so we got 31.25. 31.25. I'm going to write it there. 31.25. Show clearly on the graph how you obtain the necessary information. It has been shown. If you show on the graph, you get 1 mark. If you get your answer, you get 1 mark, and that gives you 2 marks. So let's look at the question. Calculate the focal length f of the lens using the equation u1 divided by 2. So let's look at it. u1 is 31.25. 31.25 divided by 2. It is as simple as that. 31.25 divided by 2, and that gives 15.63. 15.63. Now the next question is, state 2 precautions that you would take with this experiment in order to obtain accurate readings. Now this is a light experiment, so the first precaution that will come to your mind is for you to use a dark room. Use a dark room. That's to avoid reflection. When you are doing light experiments, the first thing that will come to your mind is for you to use a dark room. That is one. I'm going to give you like 4 precautions, so you can pick any 2. You can pick any 2 of the 4 precautions. Ensure Object, lens, and screen are vertical. Ensure that your object, your lens, and your screen that they are in vertical positions. And now, after ensuring that your object, sorry, let me change this object to small letter instead of capital letter. Okay, sorry. Then the next one, maybe I should even number it. Number 1, number 2, number 3. Move screen slowly. Move screen slowly to get the best image. Okay, I think I should give you the fourth one. Ensure object and lens are at the same height from bench. Ensure objects and lens are at the same height from bench. Okay, these are 4 precautions that you can pick any 2 from. You can also use clamp the metal rule in position. These are the precautions, common precautions for experiment with lenses. All right, I think that answers the question. Wow, we're almost done with this, and let's go to the next one. Wow. Planning an experiment. That is the last question. Planning an experiment. A student investigates the resistances of different wires. Plan an experiment to investigate the resistances of wires made from different metals. Resistance is calculated as R equals voltage divided by current. This is the formula for resistance. The following apparatus is available: ammeter, voltmeter, power supply, meter rule. A selection of wires made from different metals. You can also use other apparatus and materials that are usually available in the school laboratory. This is not compulsory, but you can use it. Now, I tell students this: whenever you have a question like this in IGCSE, you have to plan experiment, you need to note all what is written here. In your plan, you should write a list of the suitable metals for the wires you will investigate, draw a diagram of a suitable electrical circuit using standard electrical symbols. Now, you see, when you write a list, I need to tell you how the scoring is done. So write a list of suitable metals of wire. With this one, you get 1 mark. And then draw a diagram of a suitable electric circuit. Draw a diagram of suitable. When you draw the full diagram of suitable electric circuit, you get 1 mark. Now, using standard electrical symbols, you get another mark. Explain briefly how you would carry out the experiment. Your explanation on how you carry out the experiment and things like that will give you like about 2 marks. That makes it 5. State the key variables, 1 mark. That makes it 6. Draw a table, 1 mark. That makes it 7. Okay, so let's start. Write a list of metals for the wires you will investigate. What you need to do here is to look at conductors that you want to find the resistances. So let me use this one. Okay. List of wires. Conductors to be used. Let's see. We have copper. These are good conductors. Aluminium, iron, Three is enough, but I can add another one, silver. So once you've stated this, you've got your 1 mark. Once you've stated this, and what is the next question? Draw a diagram, sorry, draw a diagram of a suitable electrical circuit using standard electric symbols. Remember they said you can use other apparatus. That's if you want to use it, but if you are not ready to use it, let me just draw the diagram here. Okay, let's have it this way. A line here on okay, okay, we have another line here. Sorry, let me draw this one well. Okay, another line here. Then we have our ammeter. Let me make it the same color. We have our ammeter. Remember, ammeters are connected in series to a circuit. So we have our ammeter here. Our line continues. Okay, let me branch it this way. Okay, and let let's have the wire whose resistance we are measuring here. Let this be what the wire that we're measuring the resistance. Okay, and our line continues like this. Okay, and like this. Excuse me. Okay, this is my circuit. In the question we have voltmeter, ammeter, power supply, meter rule. This is our power supply. This is our power supply. This is the cell. This is the ammeter. This is the wire. Let me label this wire. Sorry. Wire. That's the wire that we're measuring the resistance. Wire. Okay. This is our power source. Battery slash power source. Let's have it here. Our battery or power source. Sorry. Hope it's not too small. Battery or power source. Let me make this one smaller too. There's the wire. Okay, now our voltmeter. Voltmeter is usually connected in parallel. So I'm going to connect the voltmeter in parallel to the wire that we want to measure the resistance. Okay, let's have our voltmeter now. This is V, and then we have our lines. We have our lines. We have our lines here. We have it this way. And then we have it here. Yes, this is our circuit. We have our ammeter here. We have the power source here. You can, for the power source, you can use this, and then you have your lines like this. You have your lines like this. Sorry, that was a bad line. As the power source. So this is it. You can also use other apparatus and materials that are usually available in a school laboratory. So you can put a rheostat here, but the major apparatus that you need, you have added them. So I have drawn the diagram. Let's look at the next question. Explain briefly how to carry out the investigation. Let me go to the next line to do the explanation. Now let's look at how we are going to do the explanation for this. Okay. Now what you need to do is, you have your circuit already. You have your circuit already. And now how do you measure the resistance of this wire? Let me say, start by placing copper wire in the position of the wire in the circuit shown above. Let me extend it. Connect the circuit, and please let me tell you this, it is not bad if you also put a key here. It's not bad if you also put a key there. Let me see whether is there something I can quickly do. Let's see. Let me erase. Can I erase part of the line? Cool. So let's have dot here, dot here. I have another dot here. And then this is our key. I've added a key. Okay, let's see this. Start by placing copper wire in the position of the wire in the circuit shown above. Connect the circuit by closing the key and record the voltmeter and ammeter readings. After recording the voltmeter and ammeter readings, the next thing is work out the resistance by using R equals V divided by I. That's the formula we're given. So by explaining this, you have explained how you are going to do it. Then the next thing, because you have 3 or more wires, you say, or 2 or more wires, repeat the procedure above by replacing the copper wire with aluminium and then iron, and then iron. In each case, record or measure. Okay, we are measuring. This I could work out the resistance key and measure and record. In each case, measure and record the ammeter and voltmeter readings. Okay, this is how to carry out the experiment. That's what I've just explained here. Let's look at the next thing that we are asked to do. Yes, we've written the list of metals, we've drawn a suitable scale, and we've included the symbols. We've explained briefly how to carry out the investigation then. The key variables that need to be kept constant. Now, look here, we are talking about resistance. We want to measure resistance, and then you need to look at the factors that affect resistance. The length of a wire affects resistance, the diameter or the thickness of the wire or the cross-sectional area. So these are the key variables to control. Key variables to control. They didn't really tell you the number of variables I'm going to give you. I will advise you write 2 key variables to control. One, we have length of the wires should be same, or let me just say same length of wires, same length of wires, same thickness of wires, same cross-sectional area of wires, same diameter of wires, same diameter of wires. Now, you know what? By saying same length of wires and same thickness of wires, that is okay. Now, same thickness, same diameter may be confused to mean the same thing, but I would advise you, if you are picking same length of wires, pick same thickness of wires. If you are picking same cross-sectional area of wires, then also add same diameter of wires. So let's go to the next one. What was the next question there? Okay, draw a table or tables with column headings to show how to display your readings. You are not required to enter any reading in the table. Okay, let's look at our table. We need to look at what we measured and recorded. Now, to draw our tables, let's see. I have a table like this. The materials we used, let's look at it. Materials must be on one side of the table. What did we measure in the materials? We measured the current, we measured the voltage, and we calculated the resistance. Each of these must be with their units. Okay, let's see here. Current is measured in amperes. Let me make it smaller. Current in amperes. Current in amperes. Current in amperes. We have Or should I write current or I should make it I? Okay, instead of current, let's have I in amperes. Then we go to V in volts. That's also right, V in volts. And then we have resistance in ohms. Resistance in, wow, I need to draw this. Resistance, sorry, have to come this way. Resistance, let me bring it here. Resistance, make it smaller, and then it should be in ohms. In ohms, this is the unit of resistance. Resistance is measured in ohms. Let me do it properly. Wow. And that is all. Let's see, is that the last question? Draw the table, how to display your readings. So, and that is all. All you are required to do is for the table to have the column for materials, potential difference, current, and resistance with their various units. So, students, this is the end of our tutorial today. We have successfully solved IGCSE Physics 0625 Alternative to Practical Variant 1 of the year 2020 October November. Thank you so much. Do not forget to subscribe to my YouTube channel. Turn on the notification bell icons to get informed whenever I add more tutorials, and then please share. Thank you. Bye for now.